Okay. Hello, everyone. My name is Howie, and today's presentation is about fun functional reactive programming using Scala RX. So, Scala RX is a change propagation library for Scala that I've developed over the last 2 years. It started when I was in sophomore year in college. I released it to Maven Central, and it's currently available using SVT at these coordinates. What Scala RX gives you is it gives you the idea of reactive values, which can depend on other reactive values. And by chaining these reactive values together, it is very easy to build up a data flow graph where I have some inputs, I have a bunch of intermediate values, and maybe I have some outputs at the end, which I really care about. And when I change one of these reactive values, then the change will propagate through to any values which depend on him. And this happens recursively over and over until all the graph, which depends on the thing I change, has updated. So for some motivation on why Scala RX is useful, let's consider this example we have here, where, can you see the mouse? Yep, you can see the mouse. So you have two variables. I have intermediate value C, which depends on A and B. And at the start, the C is obviously 3. But after I update A, C is still 3. So you guys may say, this is obvious. I calculated it once, and I have not recalculated it. However, this is often not what you want, because often when I say C equals A plus B, I don't just mean I want it to be A plus B now. I mean I want it to be A plus B forever. And if it ends up not being A plus B for whatever reason, often I end up with a bug in my program where values are out of sync with each other. So one trivial solution would be to fix C and turn it into a def. So this gives you kind of the behavior you want, in that now whenever I update A and I look at C, I will see the correct up-to-date value of C, in this case 6, after I've changed A from 1 to 4. However, this has some limitations. For example, what if C is not A plus B? What if C is some very expensive operation of A and B? Now every time I ask for the value of C, it will reperform this very expensive operation, even if neither the value of A nor the value of B have changed. So this is also not ideal, and although it can be solved by caching, there's another problem that's more difficult to solve. And that is, what if I want C to be A plus B now and forevermore, but I also want to have some sort of on-change listener to wait for C to change, and whenever C changes, I want to do something. I want to re-render my user interface, I want to talk to a remote web service, I want to do something that needs to be kept in sync with the value of C. Now, you can't really do that in Scala using defs, because a function definition like this one is completely opaque, and thus there's no way for you to hook in and say, I want to know when this thing changes. Even the Scala runtime doesn't know when it changes, and the only way you can know if it changes is to keep polling for changes over and over. Has it changed? Has it changed? Has it changed? Are we there yet? And the answer will usually be no, and by doing this polling, you end up wasting a lot of time and introducing a lot of complexity for something that should be relatively straightforward. So what does Scala RX give you? Scala RX gives you this example. So you import Scala RX at the top here, and now instead of using Scala vars and Scala vals or definitions, I have these capital letter vars or reactive variables and capital letter RXs or reactive values. So you notice that I wrapped all A, B, and C in these RX thingies. And now when I want the value of A, I have to use these parentheses to extract it. Similarly for B, and similarly for C. And also when I want to update the value of A, I also have to use parentheses to extract them. So now you can see that the value of C is now kept in sync with the value of A. And this change happens on this line of code. When I set A, the value of C changes before this setting of A has completed. And by the time the next line of code executes, C has already been changed. So because this is done when you change A rather than when you look at C, you don't have the wasted computation of constantly reevaluating C, even if you don't need to, even if none of its dependencies have changed. Furthermore, if I want to observe C and do something when C changes, because I'm now pushing changes from A or B to C, I can now add an observer, like I do here, and do something if C changes. For example, re-rendering the GUI, which may have rendered an old value of C, and which now needs a new value of C to show the user. So the three main atoms that Scala RX gives you are reactive variables, which are things that can be set manually and which will notify or propagate changes to their descendants. Reactive values, or RXs, are kind of intermediate values in a data flow graph. And they depend on other reactive values or reactive variables and recalculate themselves automatically when things change. And lastly, observers are things which observe changes to reactive values and do things when they change. These can be arbitrary side effects, print to screen, send a web request, re-render the GUI, any of these things. So why Scala RX? The main reason Scala RX exists is because I thought that in most large applications with lots of mutable state, a lot of the mutable state in these programs isn't really state, in that it's not allowed to vary independently of the other state in the program. It's not allowed to take on arbitrary values. Rather, a lot of state in large programs just happens to be cached computations that depend on other variables in these large programs. And it has to be kept in sync. And if it falls out of sync, you end up with weird things happening, like I added you as a friend. Why are you not showing up on my friends list? Stupid Facebook, that kind of problem. So the second thing that Scala RX assumes is that when recalculating something, very, very often you want to recompute it the same way you computed it the first time. So that's not immediately obvious, but I'm sure many of you have written programs where you call an init function once, you have a recalculate function that looks very similar to your init function, and eventually just throw away the recalculate function and just keep calling init over and over, just to make sure that this computation does not fall out of sync. So Scala RX encapsulates these ideas and gives it to you in a way that's very hard for you to screw up. So a bit more depth into what you can do with Scala RX. So consider this trivial example. I have a reactive variable A, and I have this Scala var count. So this var is not a Scala RX thing. It's just a random Scala variable that can change. And it kind of represents something that's outside of the Scala RX data flow world. So by adding an observer on A, I can now ensure that count is always kept in sync with A, even though count is not something that I technically control, just because every time A changes, the observer will trigger and send a will trigger and force an update to set count to be the value of A plus 1. So this little picture here shows what I mean. And the point is that you can then propagate changes not only within your data flow graph, but propagate changes to the so-called outside world, most of which is not controlled by Scala.rx, and most of which is not something that you even wrote. So propagation works even for larger examples, not just trivial ones like the one I showed you earlier. In this case, I have 4 reactive values, 2 reactive variables. They all depend on each other, which is shown by this graph. And when I update A here, the value of F changes correctly. So the last thing that I want to show you in this series of slides, in this short section of the slides, is what happens when exceptions happen. So everyone here knows that Scala uses exceptions not very liberally, but it uses it quite a lot for cases where something failed, and I don't want to keep using options everywhere. I don't want to keep living in a monad where everything may be either left or either right. So in this code, I have 2 reactive variables at the top. I have a bunch of reactive values, 2 of which are interesting, well, 3 of which are interesting. One of them is this one, which is because if B is 0, this should fail with arithmetic error. This one, E, should also fail with an arithmetic error. And then the question is, what happens to G? Because if C up here failed, G should also fail. So what Scala RX gives you is, it lets you propagate changes, propagate these errors forwards in the data flow graph, rather than simply throwing them up the stack and causing the program to exit. So as you can see here, despite setting B to 0, only C, E, and G have failed with exceptions, and the rest of the program can continue working fine, assuming that it knows what to do when these 3 values have failed. So enough with the talkings. Let's go look at some demos. So this is a trivial little example it's an empty SBT project. There's nothing in here except the dependency on Scala RX. And if I spin up the console, I can say, let's say, import RX. Let's say A is a var of 1, B is a var of 20, val C equals RX A plus B. So now if I ask for the value of C using the parentheses notation, I get 21. If I set A equals 10, C is now 30. So kind of cute. So what if I want to say, I want to print out the value of C every time it changes? Well, that's trivial. I can just add the observer on C and print out the value of C. So here I'm just printing to the console. In other cases, you may be re-rendering to HTML or sending web requests. Doesn't really matter. You see it printed out the value once at the start. You can tell it not to if you really want to. But now if I set the value of A to be, let's say, 100, you can see C updates correctly. Similarly, if I set B, yep. Currently, they are recomputed eagerly. And the reason for that is I thought that the ability to push changes out of the data flow graph into a real world was valuable. And for that, you can't just wait till someone asks, because that guy wants to know when you changed. So then you have to push a change throughout the whole graph every time something changes. Yeah, so I can talk more about that later. So that's basic example of Scala RX working in the console. If you want, I can show a slightly bigger example. Like let's say I take this guy and I paste him in here. Command enter. Nope, that didn't work. It's probably the PDF screwing up. Okay, never mind. So let's skip that example and let's go to the next thing, which is example using Scala JS. Who here knows what Scala JS is? Who here knows you can compile Scala to JavaScript? Well, I hope most of you do. So it actually works. So let's take a look at this short example here. I need to run SBT. I need to open up my browser. Let's bring this browser here. Let's see, you can see it spinning up. Localhost 12345. So this is a small Scala JS application. If you look at it, what it says is, this is an entry point to the program, object, entry point to the program, main method, do some things. Any of you who know JavaScript probably knows what's happening here. This is a bit of HTML that's rendered using my Scala tags HTML generation library. So let's open up the console so you can see what's happening. Come on, smaller. That didn't work. Smaller, there we go. So, and I have it set up such that every time I update the code, it should update the browser relatively quickly. So that is that's a basic hello world program using HTML. Let's say I've already imported Scala RX up on this line of code. So let's say I do the same example here. Val A equals var 1, val B equals var 2, val C equals Rx of A plus B. Doesn't really matter whether you use curlies or round braces, it works anyway in Scala. So what I'm going to do now is I'm going to take these values and I'm going to bind them to the HTML DOM. So, no, I forgot to put a comma here. So let's say I do this, and let it spin a while, and should see 3 values. And now nothing's happening because they can't change. So Scala RX is only really interesting when you start changing the variables. So let's add some on-click handlers. So on click on this div, I'm going to say A equals A plus 1. On click on this div, I'm going to say B equals B plus 1. So if I click on the A line, it'll increment it. I click on the B line, it'll increment it too. So now it's done. You can see not only is the change from A propagated to DOM instantaneously, the change to C is as well. And I can do the same with B. Let's take in a slightly more meaty example. Thanks. So let's see if I can get this copy and paste to work, because technology is very hard. Let's see. Come on. There we go. That should do what I want. So let's take this long thing. What's wrong? B got stuck up here because PDF. Okay, here I need to add a bunch more for D, E, and F, and without the comma at the end. D, E, and F. So D, E, and F. So let's spin that through. So now I have all of them, and you can see that if I make changes to one of them, you can see it propagates. So that's pretty cool, and that's basically what I showed you earlier. Let's take a look at how exceptions work here. I've already told you and intellectually that, oh, exceptions propagate forward, and you don't need to worry about them blowing up your program. You only blow up the part that needs to blow up. Let's take a look at what that looks like in code. So I have A, B, C, D, E, F, G. Hope G got chucked here too, and so did B. That means I need to add another row for G at the bottom. And let's make it decrement every time instead of incrementing, because I haven't set the variable. Oh, oops. Oh, thanks. Okay, there we go. So now instead of incrementing A and B, I'll decrement them, because when B goes to 0, stuff should blow up. So let's look at how stuff blows up. So A can go past 0 fine, and who cares? It just keeps going, and everything updates fine. If I set B to 0, you can see that only the values from which B is dependent on B, or dependent on the failing values, the values that are dependent on B will fail. And the rest of the values here, for example, D and F, continue unchanged. And if I keep decrementing B past 0, it keeps it kind of heals itself and stops complaining, and everything's back to normal again. So I think this is pretty cool behavior for something which has basically no thought gone into this error handling. It's just a bunch of code, and some of it fails. But the fact that only the things which depend on the failing things fail means that I don't have this thing blowing up my program because some idiot down there decided to divide by 0. Rather, only the guys who depend on the division by 0 will blow up, and the rest of the world can keep going on. So that's a cute little demo. So all of this is done using Scala tags, which is my HTML generation library, and this mysterious thing here called framework. So let's look at what framework is. Framework is 4 functions, and what it says is the function names are pretty meaningless. I'm sorry about that. But let's see. Let's make this bigger, then you can see more. So these things are basically type classes which determine how to bind values into the HTML DOM. So Scala tags has this type class of type node, probably not very descriptive. But all it does is it tells you if I want to take something of type a reactive value of HTML tag and bind it to the DOM, or something that takes a reactive value of type T and which is convertible to a node and bind it to a DOM, what do I do? So the answer here is I take the reactive value R, I convert it to a trie. So let's take a look at this 1 second. I have not shown you the fact that let's say val A equals var 10, val B equals Rx A, let's say 10 over A. So, and now, first B is 1. I have not shown you the fact that if I set A to 0, B will then throw an exception if I try to access it, which is, again, goes back to the idea of if you depend on these failing values, you should fail. If you don't depend on these failing values, you don't care. I can also say B.toTry, which is basically wraps the whole thing in a try for me, try catch. So that's what I'm doing over here, where if the reactive value is successful, I render its contents to HTML. If the reactive value has failed, I just chuck in some arbitrary red color span which has the name of the exception in it and render that. So, and here's a bit of code which adds an observer on the reactive value such that every time it changes, I don't want to do it the first time because the first time I bind it manually. But every time it changes, I save the new thing that changed, and I swap in. This is just plain old JavaScript, by the way, in case you guys don't know. It's not some special framework thing. I swap in the new thing for the last thing. In JavaScript, the old thing goes on the right. I don't know why. And I save the new thing. So I do similar things for binding attributes and styles, where if I want to bind RXT to an attribute, which is what this type class does, I simply say I observe the reactive value, and every time it changes, I bind it normally, like how it's done normally for that T, because it must be bindable normally because of this type class. So what this does is that it gives us this very nice behavior where not only does the DOM keep changing automatically and re-rendering automatically when I change values, if the things fail, only the parts which depend on the failing value need to fail. And not only do they fail in quite a nice controlled way where exactly the thing that's failing fails, the rest of the page works fine, and it even tells you what blew up rather than having a stack trace in the JavaScript. So that's quite a nice thing about using Scala JS, Scala RX. So now I've shown you this example, I've shown you example of exceptions. Let's look at a slightly more meaty example. So for this meteor example, and you kill SBT, I need to get rid of all my changes because Git doesn't like moving around with changes. And let's open up a separate branch. So if we wait for that to spin and compile, Oops, that did not do what I want. Here we go. Okay, so if you look up here, this is what I want. So this is a source code for a small to-do MVC application. So it's written using my Scala tags HTML generation library. Those of you who know HTML basically take this out, take out the round braces and put in parentheses, and everything will be basically the same as what you'd expect. So this is a section. This is a header, H1, setting the IDs of various parts of it. Forms, on submit, I do something, section, input, blah. And all this does is that it renders this HTML page, which is a cute little to-do MVC application. So one thing you'll notice is that when I do things in this to-do MVC application, nothing happens. So obviously nothing happens because even though when I submit this input box, I add a new task to the task list, the task list is a simple Scala variable, var, and so no one cares that the task list changed. However, if I start introducing Scala RX box vars and reactive values, we can then see this thing turn into a live updating to-do MVC application. So let's try that. Let's convert this into a var. This needs, so basically, I need to import RX everything here. So what this involves is it basically involves wrapping everything that needs to be, wrapping the Scala variables into smart variables that can be weighted on, and wrapping the Scala intermediate values into smart values that can be listened on. So that should do what I want. So this is a variable, goes to a smart variable. No, not import RX. There we go. You close the parentheses. Now these guys need to be smart variables. And after all this is done, you should see that the changes will propagate from variable to variable through all the intermediate values into the HTML5 DOM if I did not make any mistakes in doing this translation. So what else needs to be done? Done is now a smart variable, and so to do anything to the value, you need to use parentheses to extract it. Tasks is also a smart variable. And for that matter, this thing is a reactive value because I want it to update. So this works. This should be that tasks. So let's scroll down a bit. Oops, this is a mistake. So what else do I need to update? Well, this needs to be wrapped. This needs to be wrapped. This needs to be parentheses. So parentheses are actually calling the apply method and update methods, which is what does the magic. But in this case, I'm treating them as assigns because they kind of look like assigns. Not sure. So let's update these guys. So I showed you earlier that you could bind things to attributes in addition to binding things directly into HTML DOM. So here's somewhere where I'm going to bind a reactive value of basically this if statement, if else statement, to the class of this list item, which then determines whether or not it struck through or not. So it's a bit more manual translation here. Here we go. Okay, so anything else I missed out? Yep, I missed out these guys. Let's make this full screen, then it'll be easier to work with. So who did I miss? I missed out this guy because Scala equals is untyped. So this I need to get a value from the filter before comparing it to the name of the current task. So what else did I miss out? Last thing I need to do is I need to wrap the whole list of to-do tasks in a reactive value. And the reason I need to do this is because having them bound directly to the DOM means each individual task will update when necessary. But when a list of tasks changes, I want to be able to re-render and remove old tasks or add new tasks. So having each individual task but be binding to a DOM is not all that helpful. So I probably made a bunch of mistakes here. So let's slowly go through and fix them. This needs to be reactive. This needs to be reactive. Let's see if that worked. Nope. What didn't work? This needs to be parentheses. So task.text paren. This guy needs to be that. Okay, so it looks like it's reloaded. Let's reload it one more time just for luck. And now you'll see, if I did this correctly, you can see it now when I update things in this to-do MVC application, all the relevant bits and pieces change correctly. You'll notice that this variable here and this variable here, which are bound in the HTML DOM by this binding this smart variable directly. And what's the not done called? Not done is called not done, not done. And this guy is bound to the HTML DOM directly, ends up updating correctly when I change the model that backs this HTML document. Similarly, if I delete, let's say I delete something, this guy changes correctly. If I clear all the completed tasks, this guy changes correctly. Add new tasks. If I update tasks, I probably screwed up a double-click handler somewhere. So where's my page? Here it is. Yeah, so let's see. Why is the double-click handler not working? If I can't figure out with the next minute, let's just ignore it and pretend it works. Here we go. Yeah, so editing is a smart variable. So it needs to be, I need to get the value out of it, otherwise it'll always just return false. So now let's see, I can double-click edit things, save them back, it updates correctly. So that's kind of the idea behind Scala RX, in that it allows you to take code that's actually pretty imperative and convert it to change propagating functional reactive code with barely any changes to the code itself. So from a static page, this now updates correctly whenever you do anything to it, whenever you change the items in the page. And if you look at the diff between this and the original code, because we can do that thanks to technology, I think I want this one. Is this the one I want? Yeah, this is the one I want. You'll see that it's a pretty superficial, very thin rewriting. I basically changed Scala vars to RX vars, imported one thing at the top, wrapped a bunch of things in reactive variables, wrapped a bunch of things in reactive values, put some parentheses here and there, and suddenly what was previously a static HTML one-off batch rendered page suddenly becomes a functional reactive programming, change propagation, auto-updating page with a very small amount of framework code, if you can even call it a framework, which is basically this like 4 type classes. So I think that's actually pretty cool, and that's the idea for why I think Scala RX is very useful and not just a theoretical curiosity. So, now that we're done with how it actually works, thanks. So now that I'm done showing off what it does, let's take a look at how it actually works. So when I evaluate something like val A equals reactive value of B plus C, what happens is that when the RX_apply method is called, before it evaluates its content, so all this stuff is actually in a by name argument. If you really care, we can look at it. Where is it? Here it is. RX, apply. Yeah, so it's this guy in a by name argument. So because it's in a by name argument, it does not need to evaluate the contents first. So what it first does is that it pushes something onto a global or thread local stack. And when it evaluates its contents, when I call b.apply or when I call c.apply, B will look at this thread local stack and say, oh, someone is in scope. I am in someone's dynamic scope when I'm being evaluated. I think that reactive value must depend on me. So it adds this dependency between C and B and A in this case. So after that, you end up having this ad hoc dependency graph that was kind of put together at runtime, depending on who was evaluated when. And when one of the variables, like B, changes, it has a forward reference to A to say that I have changed, you depend on me, you need to recalculate now. So you guys may be wondering, so who actually recalculates when? Because you can't all recalculate now. So this is controlled by what's called a propagator. And the job of a propagator is to say, when I call var.update, because we all know that this code here is actually, let's see, where is it, this code? No, that's not it, not regex. Okay, when I call something like this, what we're actually doing is calling task.update like that. It's a syntactic sugar. So the job of the propagator is to say, determine when I call var.update, how and when do its dependencies update? Wrong. How and when do its dependents update? Because the var is a dependency and the reactive values are the dependents. So by default, there are two strategies. One is immediate, which says when I call var.update, before control is returned from the update method, I will go through all the dependents in a breadth-first topological order and try to update them. And after all those things have been updated, return from the update method. The alternative is execution context-based propagator, which says that when I call var.update, do this same breadth-first topological updating, but do it on whatever execution context is given. So this could be multi-threaded, this could be asynchronous, well, it should be asynchronous, it could be multi-threaded, and this update happens in the background, and eventually, it immediately returns a future unit to you, which if you really want to wait for it to finish, you can await on this future. Otherwise, the update just got fired off and will happen eventually. And both of these things happen in roughly breadth-first topological order. So roughly, I'll go into why the roughly is in a moment. So this dependency graph will update in something like this, more or less. So the overall characteristics of Scala RX is that the dependency graph is constructed at runtime. This means that you don't need to live in a monad where everything is a map or a flat map or for comprehension. Some people here love living in for comprehensions. I don't really like them that much. And furthermore, you don't need to specify what the dependencies are, which is sometimes quite tricky. For example, let's look at done. So done is a reactive value which not only depends on tasks, which is a reactive value, it also depends on the done reactive value of each task. So this is something that is almost impossible to specify statically. Yes? Currently, you can't have cyclic dependencies. Let's take a look. Val A equals, how do you even have static dependency in Scala? I think you need lazy val A equals Rx B plus 1. Lazy, did it disappear? Nope, that's still there. Lazy val B equals Rx A plus 1. Go. Okay, what happened? Nothing happened. Ask for value of A, boom, stack overflow, I think. Nope, divide by 0. What? Let's look at B. Also divide by 0. Well, let's restart the console and try again. Import Rx dot import Rx val A equals Rx B plus 1. I don't even know if this works in the console properly, especially IntelliJ's own weird console. A plus 1, print line A, go. Lazy vals, blah. Okay, let's try that again. So I already know the rough answer, which is that it doesn't work. I can't remember the exact failure behavior. This is probably an IntelliJ thing. So let's try doing that here in my Scala JS application and see what happens. I have no idea what's going to happen. Let's call this GG because A and B are. Okay, so print line works in Scala JS. Oh, yes, okay. Here we go. Recursive value needs type. Okay, so this needs to be a reactive value of an integer. I'm sorry, guys, but you asked for it. This needs to be a reactive value of an integer. Okay, come on, let's go. So I think what happens is that it stack overflowed, and Chrome did not like the stack overflow. So we could try the Scala console, but I'm quite sure what will happen is that it will stack overflow and throw an exception at some point. Because this guy will try to evaluate this guy, which will try to evaluate this guy, and with lazy vals, it's just the same as any other lazy val, it'll blow up. Okay, so you don't need to specify what the dependencies are, which is handy for things like this where many of the things we're depending on don't even exist statically because they're in a list which may be populated later. Other nice properties, there are no globals in the Scala RX program. Previously, I was trying to use Scala.React, which is this big global propagation controller. This one, the propagator is local and everything else is, the only thing is one thread local, which is used to track dependencies, but everything else is scoped to the propagator, which means you can easily have multiple Scala RX snippets in a larger program, which has no idea what Scala.Rx is, if you want for this small section of the program to have changes propagating nicely. It also means that it easily interrupts the non-Scala RX world. You can use it in JavaScript, I've already showed you. You can use it in the Scala console. You can use it in any larger application, which has no idea what Scala.Rx does. So limitations. The dependency graph may change shape at runtime. So reactive values may evaluate out of order or may evaluate more than once. So this sounds like a warning you get when you buy a can of milk or something. But what actually means is, let's say I have something like this, and I want to perform a topological sort on this dependency graph before I run it. Well, A is obviously at depth 0, the B is at depth 1, because it depends on A only. What's the depth of C? It could either be 1 if it depends on A, or it could be 2 if it depends on B. Well, so the thing about Scala RX is that it does not analyze these things statically, but it simply watches who evaluates within the dynamic scope of this RX call, which means that if this guy evaluated first, it would be depth of 1. If this guy evaluated next, it would be depth of 2. And next time it evaluates, the depth could change. So this eventually, so the depth of a Scala RX node can only go up. So what happens is that if this guy evaluates first, C gets a depth of 1. If this evaluates next, C gets a depth of 2. If A evaluates again, C is still a depth of 2. So the idea is that eventually it will settle on some topological order, but at least when being initially started and when I don't have all the information, it's impossible to guarantee that we are doing it in a proper topological order. And thus, what may happen is I change A, C thinks it's depth of 1, he evaluates first. Why? I don't know. Sets have non-deterministic ordering. B, C then determines that this time random is greater than 0.5. So instead of depending on A, I now depend on B. Well, B has a depth of 1 as well. So what happens is that C will finish evaluating, B will evaluate because B needs to evaluate, and B will then tell C, hey, you need to evaluate again. And C will evaluate a second time. Yes? It's possible in simple cases. So if all your reactive values are on the so-called top level, like you have a static graph, and then you can easily have a static data flow graph generated at compile time. And that is what SBT does. If you want more flexibility, like you want to be able to define data flows between things which are not static, like this fellow, which it has a data flow from a list which may have different lengths at different times in your program, then you cannot do that. And it's part of how much restriction you're willing to take. So I decided to go with a dynamic thing because I thought being able to declare done like this was really nice. And there are lots of other applications where being able to declare a dependency on something which may or may not exist is pretty handy. Okay, so next limitation. Because we use a thread local stack for this guy to detect dependencies on this guy, if you put it inside a future and runs on different thread, it does not work. This can be solved by putting in some hooks into the future. I can't remember what you call it, the thing which runs futures, execution context. But by default, I haven't put in any hooks. So this simply doesn't work. B will not end up with a dependency on A, and if you change A, B will not change. Last obvious limitation is that it's not actually that obvious. The fact that even though you can propagate changes in parallel if you give it a parallel execution context, as it stands now, you cannot initialize a data flow graph in parallel. So these two things will compute serially. But later, if you change A, they will happen in parallel. So that's a limitation of the implementation. It does not need to be the case, but it's hard to remove that limitation without either blocking threads or using Scala async or something fancier. Yes, it's the first evaluation will be synchronous. So The scope of Scala RX is used for synchronizing mutable state across your program. It is thus useless for stateless web services, which have no mutable state. It is also useless in pure functional code because you have no mutable state that's changing and needs to be synchronized. It does not support the event stream API like RX Java or the reactive extensions for .NET. Out of scope. I could have done it, I didn't. Does not support channels, coroutines, or async. All very cool. Also, I just punted it and did not think about using those. So one of the cool things about limiting the scope is that you can make it run anywhere. So I already showed you JavaScript. I already showed you the console. Apparently, it runs on Android. You guys already saw it because it's peeking up from below the page. But that's OK. So this code is not my code. I took it. Yep. Oh, OK. Hello. OK. Yeah, so apparently it works. I haven't tried it, but he has. So look for him if it doesn't work. OK, so just to recap, so Scala RX, currently the internals are kind of messy, but the fundamental components it provides are three things. Smart reactive variables, which can tell their descendants that they need to re-update. Reactive values, which form the backbone of your data flow graph and update automatically when their dependencies change. And observers, which do things when the thing they're observing changes. So this allows you to have very nice interoperability with non-Scala RX code, because non-Scala RX event-based code can easily set vars to trigger propagations in your data flow graph. For example, what I am doing here, no, that's not it. What I'm doing here, where I'm setting all these things to be done inside the onClick handler, because the onClick handler is a reactive, fancy change propagation thing. It just does things. And using vars, I can turn the do things component into propagations in my data flow graph. Reactive values are the backbone, and observers are what are very key to allowing the data flow graph to actually influence the outside world. So this fancy change propagation to HTML thing, which has now crashed and can't show you anymore, is only possible because over here, I've used observers to propagate changes from a data flow graph into HTML whenever the values in the data flow graph change. So that's very cool. Could not be done if I did not propagate changes eagerly and without using observers. So just to quickly go over some past work, because some of you have surely been wondering, like, this guy didn't come up with all of this himself. So there are lots of existing libraries which do FRP, which is called Functional-Reactive Programming, which is a broader field that contains like change propagation. So the problem with most of these is that most of them are written in Haskell or some obscure dialect of Haskell or some obscure dialect of Java or Scheme or MIT Scheme, which is even worse. And none of them interact or interop well with normal code. So I'm sure most of you will not be willing to dump your entire working application to rewrite everything in Haskell. But with Scala RX, you don't have to do that. You just need to, you can rewrite snippets at a time and have it interrupt very nicely with HTML DOM, Scala on Android, Scala Swing. You can take events from anywhere. It all interrupts very, very neatly, and the changes propagate just as you would expect them to. So some future work. So one thing that needs to be done is to clean up the implementation. So currently, the internals are kind of a mess because I include things for like, what happens if I have two threads running propagation waves on the same data flow graph at the same time, which are nice to have, and it actually works, but it's not really core to the library, and certainly isn't not useful on Scala JS, where I don't even have two threads because I have one. And in general, a lot of things need to be torn out or rethought, but the basic API will likely stay the same. Another thing that I would like to do is to experiment with a persistent file-based backend, in which, because what I'm doing right here is very similar to what SBT does by tracking dependencies between what they call tasks or settings. But I personally think that this way of doing it is much more intuitive, since you basically program as direct style code from top to bottom and have the changes propagate automatically, rather than having to mess around with SBT's task key, square bracket, setting key, square bracket. Oh no, a setting can't depend on a task. What do I do? Kind of problems. And I think that by making Scala RX persistent so that its intermediate values can be saved to the hard drive and later like unpickled and brought live again when the next run changes things, it could be generic enough to be very useful in defining workflows, for example, in a build process, or workflows in a exploratory live coding session where I'm like downloading data and don't want to keep recomputing things because computing things on big data is expensive. So if you guys like the demo, these are the libraries to take a look at. Scala JS 0.5.0 was just released by Sebastian and Tobias. It's really nice, and you guys should try it out. It's what I use to run things in the HTML DOM here, which I'm going to reopen just so you can see it again. Here we are. That did not work. Oh well. Nope. Okay. Well, never mind. You guys saw it earlier. So Scala tags is a DOM library, which I'm showing you here. It just allows you to put in HTML snippets as Scala function calls, not very fancy. Scala RX is, of course, the title of this talk. Workbench is what I use for the live reloading in the browser, which is handy if you're doing Scala JS work. And all of this can be seen on the Workbench example app on the internet, which has a live demo of the to-do MVC application here, along with the source code. If you guys want to go and poke around, download it, spin it up in SVT, it should work out of the box without a problem. So that is Scala RX. I hope you guys agree, think that it's as useful as I think it's useful. And any questions? Yeah. 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 So that. So that goes more generally. That goes into a memory model of this library. So Scala React does something where it makes this have the reference to any observables I create, which is kind of arbitrary and ad hoc. What Scala RX does is the forward references from dependencies to dependents are always weak, unless you're running on Scala JS, in which case they're all strong because JavaScript has no weak references because Mozilla hates them. So on the JVM, the different things will get garbage collected when they're no longer referenced anywhere and when you run out of memory. So if you want to keep your observer around, you do something like, yeah, you put it into a val. Oh, well, currently I'm just putting into a val, and the demos in JavaScript, I didn't put them into vals because JavaScript has no weak references, so it's all going to memory leak anyway. Okay, yeah. So generally, the forward references are weak, the back references are strong. So if you hold a reference to something at the end of a data flow graph, it'll maintain the whole data flow graph in memory. Unless you're on JavaScript, in which case touching anything in a data flow graph will maintain it in memory, which is unfortunate, but in practice it works well enough unless you have huge data sets which you're trying to maintain in Scala RX. Yeah, did I answer your question? Okay, cool. Yep. So the question is, if I have something like this, why don't I turn it into something like this? And the answer is, I don't really know. In practice, I don't think it matters. It's basically the same thing. Yeah. It was not a conscious decision. The reactive values also have a, if you import rx.ops.all, the reactive values should have a for each method, which basically does exactly that. So yeah, it was not a conscious design decision. Currently, I have only used Scala RX in one-off freelance websites and cute demos, so I haven't really stretched the limits of performance. Yeah. Questions? Where? Currently, let's see. I will return a new variable, a smart reactive value here, which will depend on this R, because when I set the observer the first time, unless I tell it to skip the initial value, it will evaluate its contents once. This new reactive value will have no reference to it. On the JVM, it will eventually be garbage collected. On Scala JS, it will live forever. Regardless, you can't do anything with it without the reference, so it just won't do anything other than take up memory. And on Scala JS, it'll also take up time as it gets recomputed unnecessarily. But it won't actually help you do anything. Questions? So colon equals is not a Scala RX operator. It is from Scala tags, which is a HTML templating library. And it basically lets you build attribute to value, key value pairs. And parentheses equals is a Scala RX thing, which actually changes Scala RX values. Yeah. Yep. So when you first build a graph, it happens one at a time. And the reason is that you don't know what the graph looks like. You don't know what the signals dependencies are until you evaluate it, because I'm capturing it dynamically. And therefore, unless I'm willing to block a thread to wait for some potentially unfinished dependencies to complete, all I can do is I can do them one at a time until they're all finished the first time. When I then make changes to this dependency graph, what exactly happens depends on the propagator. So let's look at propagator. This is the one I want. So I have two of them. Basically, they're exactly the same, except one of them is lifted in the future, and the runs are done on the execution context. One of them is done, the recomputations are done immediately. And for the one that recomputations are done immediately, what happens is, every time I compute the graph, I generate the greatest depth of each node that I compute with. And that greatest depth ends up hopefully converging into a topological ordering. And every time after that, it basically becomes a breadth-first topological computation. The immediate propagator all has to happen on the current thread, and so there is no parallelism there. The execution context-based propagator happens on whatever execution context you give it, including parallel execution contexts, but also in a topological order. So it could be parallel. There's a unit test somewhere in the Scala RX library which checks that doing it on a global execution context speeds it up by like 2x, I think. So it does happen in parallel. And if you have multiple things, so that's one part of it. What if one propagator does it in parallel? Another interesting question is what happens when I have two propagators on different threads, both running propagations over the same data flow graph? And the answer is that works. And what happens is that you may have redundant computations, but after everything has settled and become quiescent, as they call it in concurrency land, you will have valid values for all the values in the data flow graph. Another thing that's interesting is that what's the point of an observable? Because an observable, you can side effect in a reactive value, like this Scala, not Haskell, so there's nothing preventing you from doing that. But what happens is that an observable cannot have any children in a data flow graph. And thus, it is safe to wait until the entire propagation is completed before firing all the observers that need to fire. So while the intermediate values in the data flow graph may compute more than once redundantly because of problems I described earlier, every computation is guaranteed to only fire the relevant observers at most once, even if you're doing things in parallel. So that's kind of what the parallel properties of this system are. Questions? 3, 2, 1. Back at the back. Yep. So I've looked at Scala React, I've looked at Reactive Banana and Knockout JS, all of which have a similar idea. The answer is, if we put in extra effort, you can make a reactive collection that does clever diffing and doesn't, and therefore saves performance and time and compute. And I haven't done this here. And in practice, in practice, having nice immutable collections kind of substitutes that role, because updating an immutable collection is kind of efficient. Sure, it's not an array buffer, but it's kind of efficient. You're not rebuilding the whole thing. And when the update happens, I get a new value for the immutable persistent collection. It then propagates normally. But no, we don't have anything fancy. So for example, in the to-do MVC application, every time I add a task, this whole thing re-renders and not incrementally. And that could be done. If I keep doing this, it ends up being a bit slow. In practice, it takes a while for it to slow down. Yeah. Back there? Yep. Oh, well, let's take a look. Command R. If the Wi-Fi doesn't hit me, you'll see that I think it's about 200 to 300 kilobytes. So if you want to hear more, you can go to Sebastian's Scala JS talk, which is, I believe, tomorrow. It appears the Wi-Fi hates me, so you'll have to believe me that it's about... Actually, you don't need to believe me. I can look at my Finder. So this is in Personal, Workspace, Scala Days, Workbench Example App, Target, Scala 210. Well, so currently it's 1.8 megabytes because I haven't optimized it, but when you put it through the Google Closure JavaScript compiler, it becomes about 100, 200, 300 kilobytes. Yep, questions? 3, 2, 1. Okay, thank you.